Hey everybody, welcome to an extra video over 6.1 and 6.2. Just wanted to give you a few extra looks at some more problems. So feel free to skip around for what you need because this video should run about 20 minutes long. I'll go over everything as quickly and efficiently as possible, but also be still trying to be thorough. So here I'm trying to find the indicated real and nth roots for A. So if n is your root, then you're going to write the sixth root of a, negative 216. That's going to be your radical form. This is your exponential form. Exponential form has no radical, but you take that root and you write it as 1/6. If you wrote it to the 6th power, the number would get bigger. If you wrote it to the 1/6 power, the number would get smaller. But since it's a negative number and you have an even root, the answer is going to be no solution because of that, because your number was negative and your root was even. Alright? So with number 2, if I'm going to write it in radical form, I'm going to take the fifth root of 3125 x to the 10th. If I'm going to write in exponential form, I'm going to raise 3125 x to the 10th to the 1/5 power. Like I said, just throw a 1 over it, and that's how you know it's going to be a root. Anytime you see a fraction as an exponent in general, if the number is smaller on top than it is on bottom, then, or in the numerator I should say, than in the denominator, then your number should be smaller at the end. Okay, so what we're going to do is we're going to take the fifth root of 3125, which is just 5, and then you just divide. What's 10 divided by 5? Your power, and that's 2. So I'm going to have 5x squared left over. You'd put a plus or minus if your root was even, which is what I wrote here. If the root is even, the answer will have a plus or minus with it. But that root is not even. But this root is even. So just remember, I don't know, sometimes I read it and I'm like, oh, I'll put a plus or minus somewhere to remind myself not to forget that. Because I'm going to take the 8th root of 256 x to the 8th, or I'll raise 256 x to the 8th to the 1/8 power. Alright, and the answer, well, the 8th root of 256 is 2, and 8 divided by 8 with your exponents, just divide them, is 1. So I'm just going to write 2x, and then don't forget to write the plus or minus, and that's the final answer for number 3. Okay, so here I'm going to convert to rational or exponential form depending on what I started with, and then I'll simplify it as well. So looking at A, this is an exponential form, and if I were going to convert this to rational form, you would just write it as the 4th root of, and then 1296x, and then that's going to be raised to the 5th power, okay? Now, as far as solving this goes, let's talk about what the 4th root of 1296 is, and then I'll talk about that x in a moment. We'll do the 4th root of 1296 and then raise that to the 5th power. So the 4th root of 1296 is 6, but since it's a 4th root and even root, you're going to write plus or minus 6. And then I'm going to raise that to the 5th power. And that to the 5th power will be plus or minus 7,776. Okay? Now, let's talk about the x. So the x, you have the 4th root of x, raising that to the 5th power. Okay. Well, that looks kind of weird, and it might be easier to understand if you just rewrote it as x to the 5/4 power. Because x to the 5/4 power means you have, 5 divided by 4 is 1.25. So if you think about it like with money, I have $1.25. So I have 4 over 4 times 1 over 4. And that helps me because I can rewrite this as x to the first power, because 4 over 4, times x to the 1/4 power. So, and then it looks kind of weird like that, so typically it's converted back to the rational form as x times the 4th root of x. So, I have this and this for my final answer. Okay, I just split it up to hopefully make it easier to explain. And you could totally do that if you're working it out on your own. Just, put them together for your final answer. Alright? So for B, I have a square root. So I can take the square root of 49, that's plus or minus 7. I could take the square root of y to the 6th, that's just going to be y to the 3rd. Now, what am I going to do with this x to the 5th? Well, because it's an odd number, that's why I'm drawing attention to it. So you're trying to take the square root of x to the 5th, or you can split that up as x to the 5/2 power. And then just think, what is divisible by 2? 2, 4, 6, 8, 10, 12. Okay, well 2, 4, I can do 4. I can take 4 away from 5. That's what I'm trying to get at. So I can split this up as x to the 4/2 times x to the 1/2. Alright, so x to the 4/2 would just be x squared. And so I have x squared times x to the 1/2. Alright, so meaning I have x squared on the outside and the square root of x left below on the inside. And that's going to be the final answer that I'll need to rewrite in there. So you typically will just see square root stuff added on, or radical stuff I should say, at the end rather than in the middle. So the answer should actually look kind of like that. But I guess if you put it, just stuck it in the middle there, it'd still be fine. Just it would just look slightly improper. So for part C, you need to recall what is the definition of a negative exponent, and that is it's a fraction. So if you see a negative exponent, put it in a fraction if it's not currently in one. If it's currently in one, just send it to the opposite side of the fraction. So now I have a positive 6 as my exponent. But I still have a negative 2/3 as an exponent. So if sending x to the 6, negative 6 to the bottom made it positive, well then if I send x to the 6 to the top and 27 to the bottom, in other words, I flip it, I'll have a positive 2/3 now. So x to the 6th over 27 raised to the positive 2/3. Okay, so that's all you got to do for that. And now that it's in the proper exponential form, I can rewrite it in my radical form, because we've been doing that with all the other ones. Although now that I think about it, we skipped it on this one. So I'm going to write 49 x to the 5th, y to the 6th, and then the exponential form is raising it to the 1/2 power. Sorry about that. So back to converting this to the radical form. The bottom number is your root, so the bottom number is 3. So I'm going to take the 3rd root of x to the 6th to the 27th, and then I will square it. Okay, so let's talk about what the 3rd root of x to the 6th is. That's just going to be x squared, because it's just 6 divided by 3. What's the 3rd root of 27? That is 3. So I have x squared to the 3rd power, and then I'm going to square that. What's 2 times 2? 4. What's 3 to the 2nd power? 9. So that is my final answer to C. Alright? No plus or minus because I squared it. Squaring is not the same thing as square rooting. So square rooting gets plus or minus, squaring does not. So for part D, it's in radical form, the exponential form, 81 x to the 8th, and then it would just be 5/4 because the bottom number is the root. Okay, feel free to solve it however you want. I prefer actually the first kind of form. I'm gonna leave that there and have it set aside. But let's talk about what the fourth root of 81 x to the 8th is. Well, the fourth root of 81 is 3. Don't forget a plus or minus since it was fourth root. And then the fourth root of x to the 8th, 8 divided by 4 is 2. So I have the fourth root of that is plus or minus 3x squared. So we just need to go back in and raise that to the 5th power. Alright, so 3 to the 5th power is 243. So I'm going to write plus or minus 243. And then x squared to the 5th power is x to the 10th. And so I get 243 x to the 10th. And that's all I need to do on part D. Okay, so just to wrap things up on that section, just remember if the denominator of the fraction is even, then the answer will have a plus or minus with it. Here we are solving equations using nth roots, or nth powers, I should say, because this one already has a root. But remember, if the root is even, the answer will have a plus or minus with it. Okay, so for part A, you have a 1/2 on the outside of parentheses, so you need to get rid of that first. So what I'm going to do is I'm going to flip the fraction, that would be 2 over 1, and then I'll multiply. Alright, so multiplying it to both sides, of course, and I just need to do what's 8 times 2. So 8 times 2 is 16, and that's just going to bring down x minus 4 to the 4th power. And so now anytime you have to get rid of a power, just take the root of that number or raise it to the 1/4 power. Yeah, the 4th root of 16 is plus or minus 2, and then you have just x minus 4 left over. So all you have to do is add 4 to the other side. And so you have x equals 4 plus or minus 2. That's pretty easy to figure out. What's 4 plus 2? That is 6. I almost started writing the 6. What's 4 minus 2? That's 2. So 6 and 2 are my final answers. So for B, there's nothing on the outside of the square root as far as like I gotta times or divide something, but obviously you need to minus this 3 out. So you have the square root of 2x equals 16. Well, it's just like the powers. What's the opposite of a square root? That'd be the power of whatever that root is. So power of a square root is 2. The opposite of it, yeah. I feel like I said that word. But yeah, 2x squared, when it's square rooted, just leaves behind 2x. And 16 squared is 256. So just divide by 2. And x equals 128. And that's it for that one. So for part C, there is a 2 on the outside of the parentheses, which means I'll have to divide. But you should always add or subtract first. So I'm going to minus 7 over before I do that. So 2 times x plus 2 raised to the 3rd power equals 54. Which means now I can divide by the 2. And 54 divided by 2 is 27. And so now I need to get rid of the 3rd power. So I'm going to take the 3rd root of both sides. So that leaves behind just x plus 2. And the 3rd root of 27, or the cube root of it, is just 3. And so what number plus 2 is 3? 1. 1 plus 2 is 3. And that's it. So this next section, using properties of exponents and radicals, we're just going to try and simplify. Yeah, there's really nothing much to it. So you have 4x squared. Look at the parentheses, inside the parentheses. 4x squared over x times y to the negative 5th. You see a negative exponent, send it to the opposite side of the fraction. I have an x squared on top and an x on bottom, so I know that x squared divided by x just leaves behind an x on top. So I'm going to have 4x y to the fifth, and I'm going to raise that to the second power. So 4 to the second power is 16. X, raise it to the second power. Y to the fifth, raise it to the second power, do 5 times 2. And that's it for number 1. Number 2, what's x to the sixth divided by 3? That'd be x squared. The cube root of 243 is, 343 is 7. And then you just have to talk about this. What is the third root of y to the fourth? Well, I'll do that in red. The third root of y to the fourth is the same thing as writing y to the 4/3 power. And why is that useful? Because you can split that up to, say, 3/3 times 1/3, because 3 plus 1 is 4. And 3/3 times 1/3, that means y times 1/3, or that means y times y to the 1/3, which I forgot to write right there. There we go. And so that is the same thing as saying y times the third root of y. Okay, so that goes right here, y times the third root of y. Okay, now typically we'd say, hey, that's the answer. The fun part is we have a radical left over on the bottom of our fraction, and you can't have a radical left over on the bottom of our fraction. So you got to go back, erase that circle, because this is not your final answer. And we need to get rid of that radical on the bottom. So what do I need to multiply the cube root of y by to make it just like a regular y? And I can just do that by multiplying it by the cube root of y squared. Why did I choose to do that? Because you would add the exponents. Y to the first power times y squared is y to the third power, and then the cube root of y to the third is just 1, 3 divided by 3. And what you add on bottom, you have to add to the top. Alright, so let's finish the work down here. I have x squared cube root y squared over 7, and I'm just going to write everything down again. 7 cube root of y, cube root of, or it would be cube root of y cubed, I should say. And then the cube root of y cubed, that just turns into y. And so I now have x squared cube root y squared over, and then y times y is y squared, so 7y squared. So the answer looks kind of weird, and the rationalizing step always kind of loses some students. But just know the reason why we do it is because for some reason it is like improper to leave a radical on the bottom of a fraction. So you need to get rid of that radical somehow, and you know, you'll generally see it written right back up on top in some form, because it wasn't exactly the cube root of y on top, it was cube root of y squared. But yeah, that's all of number 2. Number 3, see I have 10 square root of 2x minus 4 times square root of 18x. I need to split up this square root of 18x. The reason why is because I can simplify that. How do I know I can simplify it? Well, I know 18 is 9 times 2, and I gotta throw an x in there. But look, also think of it like this. 2x, that can't simplify. 18x, it's a bigger number, so it can probably simplify. So just do, what's 18x divided by 2x? And that would leave behind a 9. And so when you split it up, that's how you kind of know how to split it up. Bring everything else down. So 10 minus square root 2x minus 4 times square root of 9. So what is the square root of 9? That is going to be 3. So this turns into 3 square root 2x. And again, just keep bringing things down. But it's going to be 4 times that. 10 square root 2x minus that. What's 4 times 3? That's going to be 12. So I have 10 square root 2x minus 12 square root 2x. And 10 minus 12 is negative 2. And then just have square root of 2x with it. That wouldn't like disappear or anything like that. But that's all there is to number 3. Bit easier than the last one, I think. So for 1 and 2 in the next section, rationalize and simplify with conjugates. This one, for whatever reason, when it formatted, the square root sign looks kind of weird. But the conjugate, just take whatever's on the bottom, square root of x and a 2, put it in a fraction over itself, and then whatever the sign is in the middle, just change that. So it's a minus sign now. So the top you'll have to distribute, so that'll be 5 square root x minus 10. And then the bottom, remember the bottom, you're practically just squaring each term. It's the difference of squares pattern. So the square root of x squared is x, and then 2 squared is 4, and then you would just have to put a minus in the middle, and that's the final answer. That's all there is to it. So number 2, I'm going to take 4 plus the square root of 3 and write 4 minus the square root of 3. 4 minus the square root of 3. This is multiplying using the conjugate, or rationalizing, yeah. And then just distribute a negative 2, negative 8, plus, and then you just have the number on the outside. You wouldn't do 2 times 3 and put square root of 6, okay? That's not the same thing. And then the bottom, 4 squared is 16. Square root of 3 squared is 3. So I have 16 minus 3. It's always going to be minus. And so the final answer is negative 8 plus 2 square root 3 over 13. And yeah, that's it for that little section. So the last section, solving with rational exponents. Well, it's kind of similar to what you did before. If you have a fraction of an exponent, or if you have a fraction, you flip it and you multiply it to the other side. So if you have a fraction as an exponent, flip it and raise it to the power to both sides. So that'll cancel out that exponent there, just leaving behind an x plus 2 here. So I really don't even need these parentheses. And x plus 2 is going to equal 8 to the 2/3. And so the bottom number is the root, and the top number is the power. I prefer to write it like that. It's easier to show my work. The cube root of 8 is 2, and 2 squared is 4. So I have x plus 2 equals 4, okay? And what number plus 2 is 4? That's 2. 2 plus 2 equals 4. I don't have a plus or minus answer because it was the cube root. That's an odd root. And so, yeah, 2's the only answer for that one. Number 2, it's to the 3/4, so I'm going to raise it to the 4/3 or multiply it to the 4/3. I don't know how to really phrase it. And so I have x minus 3 equals the cube root of 8 raised to the 4th power. So the cube root of 8 is 2, and 2 to the 4th power is 16. So x minus 3 equals 16, which means the answer is going to be 19 because 16 plus 3 is 19. So thanks for watching these extra examples. I hope this helped. And thanks for watching the long video. Bye.